Okay, now we're going to talk. We talked before about the elemental level and materials at elemental level. Now we're going to talk about the general classifications that engineers use. And it basically falls into one of these four categories: metallic, ceramic, organic, and polymeric. And we're going to talk about each one of them in detail. And these are the basic ones. And then we can also have another classification that's a composite. Basically, composites are combinations of any of the above types, so I don't really consider it a separate one. We're going to talk about what it means when it's a composite, but basically it's just a combination of one of the other ones. And we're first going to start about metallics. And we have pure metal elements. They're just like the metal elements we talked about earlier. However, metals are rarely found in their pure form, and it's very expensive to get them back to their pure form. It takes a lot of processing, a lot of refining if we want to get pure iron or pure gold. So really, most of the time, everything we do is with alloys and engineering. And we know from before they're good electrical and thermal conductors, and they have the same kind of properties in general that we had earlier. Even when we start mixing the metals together in alloys, we're talking about compounds, and they still maintain all those metal properties we talked about earlier. A big classification in metals is ferrous versus non-ferrous. And here's some basics. You don't need to copy this whole chart down. Just understand the basic differences here. Basically, it's a ferrous metal, like Fe, like Fe is iron on the periodic table. If it has any amount of iron in it, it's ferrous. That means that it has magnetic properties, because only iron has magnetic properties, not the other elements. Iron also has high tensile strength. That means tensile means we can pull it out like pulling a rubber band. It oxidizes, in other words, it turns to rust, and that only happens to iron. So anything with iron in it will rust. When we need it to be magnetic, we just said that iron's the only one that's magnetic. So this is kind of our dividing line here. Anything with steel, iron, is going to have iron in it. And then our other ones over here don't have any iron, and so they don't have those properties. Here's a little picture of how it's broken up. Again, you don't need to copy this down. I just want you to kind of look through it to understand the basics of it. Metal is what we make our cutting tools out of. Here's all our ferrous materials on this side. So these are magnetic and can rust on this side. And then our non-ferrous over here, it looks like a lot of them, but they have lower strength, so we don't use them as often. Note this little one right here. And then we have our alloys. Did you know that brass is actually copper and zinc? And solder that you use, for example, on circuit boards is actually lead and tin. Just a little bit of trivia there. Alright, now we're going to move along to ceramics. Ceramics are actually used a whole lot. When we hear ceramics, we might think of pottery and coffee cups and things like that. But ceramics are actually used in lots of places. And for instance, these little white parts up here on the electric poles, those are actually ceramic insulators. They keep the electricity from jumping from the electrical lines to the pole. And ceramics are good electrical insulators. They're also good thermal insulators, meaning that we use ceramics whenever we want to keep hot things hot or cold things cold. Our fiberglass insulation and basically all the insulation in your coats, when you have a squishy coat with the insulation in there, all that is made out of ceramic materials. And the properties, it includes high strength at high temperatures and brittleness. It is brittle, but it is good at high temperatures. For example, when we had the space shuttles, they actually put ceramic tiles around the nose of the space shuttle because as it goes through the atmosphere, it would get very hot. Here's a couple of kinds that you do need to take notes on and be sure that you have. The first one is clay, and we use clay actually in all sorts of places. These are concrete pipes, bricks, concrete bricks. Anything like that is shaped, dried, fired, and they're inorganic materials. And here are some examples. Also, we have refractory, and that's what I was saying, these little blocks on the nose of the space shuttle. They're designed to withstand high mechanical and chemical extreme temperatures. For example, right there. We also use ceramics in all sorts of electrical applications. Basically, ceramics, as we said, resist electricity, so they're used for all these different parts.